Hello and Assalamualaikum. My name is Muhammad Ishraqi bin Lisa and today we are presenting for PGT 206 Computer Architecture on topic mini project. So basically our group consists of 4 members, which is me, Muhammad Afif, Muhammad Izzat and Muhammad Aiman. So for this project our group using a few arithmetic logic unit, ALU, and for my part I'm explaining for subtractor and AND gate. So for subtractor, we use 3 input and 2 output, which is input B in, IA and IB, output B out and OD. We are using array to get a bit. And then for clearly view for this program, here is the block diagram, which is input IA, IB, B in, and output OD and B out. So TB we declare as temporary output, and here is the module. So here is the test plan for subtractor. You register DC, DA, DB using array, wire B out and OD. So if this program doesn't get any error, we will display Y adder sub AP verified. Here we call back module subtractor 8-bit. Then we will so estimation. Not active. Here is the waveform. So it doesn't get any error and display Y adder sub B verified, same as we declare. For AND gate, AND gate we use 2 input and 1 output. Input IA and IB, output OY is module, and test pen. We use array for to get 8-bit, which is register DA DB, YOY register TY. And for this program got loop 65,536. And before I forget, subtractor 8-bit also get loop, which is 32,768. And is this program got error, it will display it's a fail. If no, it will run looping and get Y logic and verified. So here we call back AND gate 8-bit module. Simulate. So here is the way for AND gate 8-bit. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif Farhan bin Lokman. So today for my explanation is I will explain about AND gate and adder. So for the AND gate 8-bit, they have a two input and one output. The difference between AND gate 1 bits and 8 bit is in the input, output and the wire. As we know that we use 8 bit, so we need to put an array in this input, output and wire to get the final answer is 8 bit. So this is the test bench for the 8-bit, Engage 8-bit. First, the module and the register, input, wire for the output, and register for the TY, and call for the Engage 8-bit. So we can see that the final answer, the result. Okay, this is the result for the 8-bit. You can see that they use a 8-bit. So next is for the next we go through the adder. In our project we use adder 8-bit. Adder have three input and two output, which is the input is Cin and IA and IB, and for the output is Cout and OS. So in this module we use the method that we call which mean that we call the adder 1-bit. This is our adder 1-bit, which is we construct is manually, and in adder 8-bit we just only call the adder 1-bit, but we use array to make it be 8-bit, same to the Engage. So we call it one by one, but the difference is between what we call it TC and the output. The output will connect to the input on the next adder 1-bit. That's all. And we can see the result. In the test bench. Oh, forgot. Okay, this is the test bench for the adder 8-bit. So we call the adder 8-bit and the input and output. So next we see the wave. So this is the result for the adder 8-bit. And adder and Engage we construct X in a one ALU. So the input for the Engage is the input for Engage and sub come from the data out, and another one is come from the register. So the output will go to the Z buffer, same goes to the adder.
Assalamualaikum. My name is Muhammad Izzat bin Aziz. In this video, I will present about module decoder 224, Z buffer, and register. Okay, first, this is the coding for module decoder 224. Okay, I compile. Okay, compile decoder 224 was successful. Next is okay for test bench. Okay, And next, I will simulate the decoder 224 test band. Okay, this is the waveform for test band for decoder 224. Okay, next the module is Z buffer. Okay, this is the module for Z buffer. Okay, output decoder 224 will be which AND gate and which read enable. Then make input for Z buffer to read. Okay, next is for module register. Okay, we compile first. Okay, next for register test band. Okay, then we simulate for we run for waveform for register. Okay, we run. Okay, this is the waveform for test band for register. Okay, lastly we use 224, so we have 4 ALU in this register will be used in the red block. And the top level ALU where the input come from the red block output, in red block we use 8 register because our project we use 8 bit. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Ahmad Akib Syamsul Kaha. Program RY41, metric number 19139258. I want to present my contribution for the mini project. So I did the red block for 3 to 8. This is my module, and this is my test bench. This is based on the truth table. So this is the output. Here's an output. So you can see here that my decoder is verified. Okay, for the next one is for the right block. This is my right block. I built this right block uh, based on the block diagram. Based on this block diagram. So see, okay. First, we need to call the 3 to 8 decoder. We have right here. The first part is the write enable. The second part is the read enable. So we got two 3 to 8 decoders that will need to connect to AND gates with the enables. Then connect the output of the AND gates into register with the data in. Also with the clocks. So this is the code. This is the codes. This is the second part for the address read. Then after that, we need connect the output into the Z buffer. Yes, okay. This is the code for the Z buffer. This is the read enable output. Read enable with AND gates. They connected to AND gates with the decoder 3 to 8. This is the output of the register, and this is the output of the Z buffers. So where the task bench? Right, this is the task bench that I did. Yeah, I'm not sure about my task bench. Basically, the first one we just data in 0001. Then 0010. This is based on the output of the decoders, 3 to 8 decoders. Then I just simulate this. Right block. Right block. Okay. So this is the output of my signal of the red block. When 0001 will be output to 0001, and 00010 will be output 0010. But there's a delay right here. I'm not sure about that. About this. But this is my output. So for the last one, is my high level, top level ALU. Top level ALU. Okay, this. So this is my code. But I didn't finish with the test bench. This code I based on the block diagram. So we call back the red block. Then there's a temporary register that we connect it with the ALUs. The output of then there's the decoder. We connect to the read enable 2 to 4 because we have 4 ALUs. Then the output of the Z buffers is based on the input of the read enable from the 2 to 4 decoder and the output of the ALUs. So that's all. Thank you.